Today let me learn about how to minimize a 5 variable function which is in SPOS form using K-map method. Now in last session we learned about how to minimize your SSOP function using your 5 variable. Now here how to minimize your 5 variable function using your K-map method with the given variables of f of a, b, c, d, e is equal to pi m of 3, 5, 6, 9, 10, 11, 13, 19, 21, 22, 23, 25, 26, 27, 29. As the given variables are in the SPOS, so which is standard product of sum terms. So sum term functional values are zeros. So map your functional values onto the corresponding cells of your each cell of your K-map, 5 variable K-map. A 5 variable K-map is implemented using two 4 variable K-maps. So top layer is having A0 and bottom layer is having A equal to 1. Now upon mapping your function, let me check for your the greater square adjacency. So our bigger square adjacency. Now let me verify. So your adjacency of the cells. Now here M9. So capital M9, maxterm M9 is adjacent with your M13, M25 and M29. So your maxterm M9 is adjacent with your maxterm M13 along with M29 in the bottom layer and M25. So this can form a quad. So now a quad or a first group, so which is on your top layer of this 9, 13 and bottom layer 29 and 25 can form a quad. So if those two are forming a quad or 4 square adjacency, let we call like that. So that 4 square adjacency, this belongs to A0, this belongs to A equal to 1, so different, so they may not come. So row wise B is 1, so B bar or a column wise DE for those are belongs to the second column, so D value 0, D or of without complement we have to represent where D value is 0. So next E is 1, so hence E bar. So now, so this is your product term of your first group of 4 square adjacency. Next M13 is adjacent with M11 in your top layer along with in bottom layer it is also adjacent with M19 and M27. So here the third column element of top layer and the third column elements of bottom layer 19, 27, 3 and 11 are adjacent. So a quad is formed with that given maxterm. So now, so A is different where row wise, so C value 0. So here C value is 0 and in column wise D and E are 1s. So C or of D bar, E bar. Next maxterm M5, M13, M21 and 29. So M5, M13 already we covered this. So in order to cover uncovered maximum of M5, next M21. So we are using your already covered maxims of M13 and M29. So these two are in top layer of second column and these two are in bottom layer of second column. So now, so these are different. A value is different, so it may not come in your product term. So the same variables row wise is C value is 1. So hence C bar, and here they belong to the second column D or of E bar. Next M6. M6 is adjacent with M22 in your bottom layer. So this M22 and this M6 are forming a pair. So now A is different but it belongs to the same row of BC value 0, 1. So B is 0, so without complement. C is 1, so with the complement we need to represent, and they belong to the last column where it is DE values are 1, 0. So DE is represented with the complement D bar and E is 0, hence without complement. So the sum term is B or of C bar or of D bar E. So for the pair combination of M6 and M22. Next the max term M10, M11, M26 and M27. So now M10 on your last row we have M10, M11, M26 in the bottom layer and M27 are adjacent, can form a quad. So this quad formation can eliminate different variable A, and it will give you the common variables which are BC, where B value is 1, so B bar, C value is 0, so C. And in column wise for this 2, so D value is 1, so hence D is D bar is represented in your sum term. Next, the last group, which is M22, is adjacent with not only with the 6 on top layer but also in the bottom layer. So 22, 23 are adjacent. So hence we can form a pair. So now this pair can eliminate one variable, and these 22 and 23 I belong to the A value 1. So A bar, and these belongs to the second row where values of B is 1. So B is 0. So without complement, C is 1. So with complement we represent it, and they belongs to the columns of 3 and 4. So 3 is 1 1, 4 is 1 0. So 1 belongs to D. So D bar. So is the last group sum term by adding all these 5 group sum terms. So by just multiplying all these sum terms, we would get your F minimum expression, which is B bar or of D or of E bar and of C or of D bar or of E bar and of C bar or of D or of E bar and of B or of C bar or of D bar or of E and of B bar or of C or of D bar is your minimum D bar. Along with here we have your minimal expression, which is here it is B bar. C or of D bar is the minimal expression of your given function. So with all the 5 group elements. Another example we have given to solve using your max terms. So your given functional values are 0, 2, 4, 7, 8, 10, 12, 16, 18, 20, 23, 24, 25, 26, 27, 28. Now mapping your functional values and checking for your adjacency. Now here, so on your top layer, so your given variables are 5 variables. So here 0 is adjacent with 4, 4 adjacent to 2, 12 is adjacent with the 8, as well as 0 is adjacent on your bottom layer 16, 4 is adjacent with the 20, next 12 is adjacent with your 28, so 8 is adjacent with your 24, so you can form a octet. So this first group is forming an octet, so which can eliminate almost 3 variables. Now Q, R are eliminated because for this 4 max term and these 4 max terms it is different. So 8 max terms common variable we need to find. So here P value is 0 for this 4 max term, P value is 1 for this 4 max term. So A value is P value is also eliminated. Only we have S and T, where S value is 0 because they are belong to the first column, and T value is 0. So first group sum term is S or of T. Next, so next max terms are 0 is adjacent with 2, 0 is adjacent with 8, 8 is adjacent with 10. The bottom layer, the 0 is adjacent 16, 2 is adjacent with 8. So 8 is adjacent with 24, 10 is adjacent with 26. So top layer 4 corner cells, bottom layer 4 corner cells are adjacent. Hence they also form an octet, so which is a group 2. So the octet 2, so it can eliminate the different variables which are P along with your variables of Q. So it will only give your R with a value of 0, hence in your sum term it is represented with R, and in column wise, so they belong to the first and last columns, so hence T value is a 0, so R of T, R T. So is the minimal expression sum term of your octet 2. Next, only 2 max terms are here are forming a pair. So this 7th cell is adjacent with 23rd cell of your bottom layer. So hence So this is, if I consider it as a group 3, so it forms a pair. So pair eliminates only one variable as they are belong to P0 and P1. So the different variable of P is eliminated and the common variables, it belongs to the second row, which is Q or of R bar, R of, and they belong to the third column, which is S and R. T R values are ones. So hence your third group minimal expression is Q plus R bar plus S bar plus T bar. Next, only two maxims are left here, 25 and 27. So we are going to use already covered maxims 24 and 26 in order to form into a big square, which is a quad. So this is the last group, which is a fourth group. So it is having four groups. So group 4, it belongs to P equal to 1. So P bar is your first sum term variable of this group and it belongs to the last row, so which is 1 0. So Q bar or of R is your minimal expression of this quad. So now if I multiply all these sum terms, so then I would get your actual minimal expression, which is S R of T and of Q or of S bar or of T bar with the pair, and your another octet, which is R or of T, and a quad which is on bottom layer, which is P bar or of Q bar or of R. So like this we have to minimize your functions and we need to draw the logical diagram of your given functions upon minimization.